Thank you all for being here. I didn't expect this to be such a full room. It makes me a bit more nervous, but hopefully everything will go okay. So I'm here to present the work that me and Francesco have been doing with regard to OGC API processes and Pygeoapi. And oh, sorry. Okay. So I'll start by giving you a brief overview of what are OGC APIs, just to make sure we are all up to speed. So it's the next generation of geospatial standards, which aims to be easier to consume, easier to integrate with than the previous OGC web services. So it fully embraces the HTTP way of building stuff for the web, so using status codes, using HTTP verbs, headers, and etc. They use JSON, and they are described with OpenAPI. So the main aim, at least the way that I see it as a developer, is to really make these new APIs something that is easy for developers to use and to bring it onto their systems. So there are a number of OGC APIs. We are focusing now on OGC API processes, which is basically a way to offer geospatial computation as a service. So the idea is that a server can offer a number of processes that are available for being called over the web by a client, and these take some input, generate some output. They don't really need to be to have a geospatial context, but I guess that's the main purpose. They are resource-centric, meaning you can build modern APIs and clients on top of them, and hopefully they are easy to work with and easy to put on all the things. So this is just a very, very brief example, just so that you can see how there is a resource endpoint just to list processes that exist on the server. There is also a resource endpoint to get information about a certain process. And if you want to execute a process, you just call also this resource endpoint. You give it some HTTP header, you give it some inputs by means of a JSON object, and even though I didn't have any space to write it here because of the size, this is doing an HTTP post request. So it's just a very quick example to demonstrate how OGC APIs are really embracing the standard way of building APIs nowadays for the web. Okay, so in OGC API processes, as I was saying, we have the concept of a process, which is just some workload that you are offering to a client to do, taking an input and producing an output. So both inputs and outputs can be specified by a number of different ways, by direct upload, by reference. The processing itself can be done either synchronously or asynchronously, depending on the capabilities of the server and also on the process. Synchronous means that the response, the generated results will be coupled with the HTTP request response cycle, so potentially it will block the client. So typically this can be used for processes which are very lightweight. The asynchronous mode will signify eventual execution. So whenever the server has available resources, it will fulfill the request, and it hands back some URL that the client can check back later when they want to get back the results, or just to see if the status of the processing is done already or not. There is also a feature too, instead of polling the remote to check on the results, you can also ask to be notified when they are ready. So this is just, I'm just putting in here some relevant parts of the standard, okay? Okay, so moving on. The work that we are presenting has been done in the context of Pygeoapi. So now I will just, I just wanted to make a brief overview of OGC API processes before we move on, so that we get a clear picture of things. So I think probably most of you are familiar with Pygeoapi, but in a nutshell, it's a web application that focuses on implementing OGC APIs and developed in Python, has a growing number of standards either implemented or being implemented, including our dear OGC API processes, but there's support for a growing number of standards, some of which are becoming reference implementation, so something that can be really used to showcase what the standards are and how to interact with them. Pygeoapi is very interesting also from a developer point of view because it is very modular and flexible. So we can interface it with practically anything because it leads itself to have plugins bringing additional functionality. And this can be done either by extension or even by replacing. So you can add additional data providers, you can define your own processes, which is what is relevant for this talk, and also replace the core, in this case, process manager with your own, which is what I will be speaking about in a moment. This is just to speak about how Pygeoapi is an attractive platform as a developer for this kind of work. Okay, so how does OGC API processes work in Pygeoapi at the moment? So the implementation of the published version 1.0.0 of the standard is ongoing. Okay, so there is already support for Pygeoapi processes in Pygeoapi, but I guess this is actually something that came before my time. Maybe Tom can speak about it if relevant. But the support that is in there does not reflect the published version of the standard as of this day. But it will get there eventually and hopefully very soon. Nevertheless, it is supported. The internal architecture uses, as I was saying, a pluggable process/job manager. I'll refer to it as process manager just for brevity, and pluggable processes, meaning that you can basically put there whatever you want as the process is offered by your deployments. So the process manager has a number of responsibilities that it fulfills and kind of shields the rest of Pygeoapi from having to deal with these details. And therefore, if we just replace it with some other thing that we build, it will still work together with the rest of Pygeoapi. If that makes sense, what I said. Sorry if some things... So this is a very brief, really brief overview of Pygeoapi when looked at from a Pygeoapi processes lens. Okay, I don't mean to treat Pygeoapi as a whole here. Just what I'm speaking of. So, client makes a request, which is parsed by web frontend. Web framework, which by default is Flask, but there is support for others in Pygeoapi. Then there is a core API class which does some parsing of the request parameters. And in the case of processing, it hands over to a specialized class, which is the process manager, that then takes over what needs to be done to fulfill the request. So if we just swap this part out with something else, it will take advantage of what came before, and this attests to the flexibility of Pygeoapi. So process manager will usually instantiate a job based on its configuration. The job can be executed synchronously or asynchronously depending on the request and on the server capabilities, and eventually some result is generated, regardless of the result being generated, the job has already given a response saying, okay, I will do it when I have the time, or I have already done it and here is the response. And when we are just querying for the results, it's similar. We still go to the process manager, and then the process manager is responsible for getting the result from wherever it is stored and giving it back to upstream, whoever is calling it. Okay, so the whole point of this work that I'm describing is that we wanted to enhance Pygeoapi's process manager with something that would be already robust and would be in application in other parts, in other industries as well. So for this reason we have chosen Prefect, which I'm not sure how familiar you are or are not with it. So it is a workflow orchestration platform. So it can be used to basically set up complex workflows, and it contains many additional tools which you end up needing when you are managing workflows, like like monitoring, like retries, like scheduling, like storing your results at different locations. So it's a very robust system that is used in the in context of orchestrating complex workflows. So we thought, okay, maybe we can put Pygeoapi in front of Prefect and benefit from all of the Prefect features in terms of being a very robust workflow orchestration platform. And this would give us a nice marriage of features, so to say. So Prefect also has a very nice user interface, which we can use to monitor not only in real time what is happening, but also have a good historic view. So it gives us a platform for us to manage our process-related processes? No. If you know what I mean. So this is a very robust system that we can actually put to work behind Pygeoapi. So this is really what I mean. In a nutshell, Prefect's architecture uses a neat hybrid model in which there is a kind of, let's say, orchestration plane, and there is a workflow plane or infrastructure. And these two components are really well separated, which means that we can have these components running on some cloud, or even the Prefect, the guys that make Prefect, they offer a managed Prefect cloud where you can, if you want to, run this part of the component. You can also run them on your infrastructure directly, or just on a laptop or whatever, okay? And then this kind of workflow part of Prefect, you can also run it somewhere else if you want to. So this is good in terms of security. If you want to make sure your data doesn't leave your premises or something like that, but still want to take advantage of some managed platform for the orchestration part, is a nice feature. And Prefect itself works in a very distributed way, in a very cloud-enabled way, if you will. So on one hand, we have the actual processes, or as they call them, flows, which are the code for the tasks that you want to be run. And then this code can be deployed in a number of different places according to the configuration. So you can, for example, say that you want to run them locally, or you can just say, I want to run this on a Kubernetes cluster, or I want to run it on some remote server that I control, or in a Docker container. And then when the results are generated, you also can say that you want them to be stored on S3 or on your local machine, or basically wherever you want, which is very nice because it means you can scale to whatever whatever is the appropriate dimension for your applications. Okay, the main building blocks when you write a Prefect workflow are just normal Python functions, and they are decorated with either flow or task, and these come from Prefect. But the main point is that it's just normal Python code. You don't really have to work out too exotic data structures, or you don't have to adapt to any funky APIs. I'm going to skip ahead a bit because the time is running out. So I guess the takeaway for us when we started doing this work is that Pygeoapi and Prefect would really be a nice couple if we were able to integrate them successfully, because it means you get the interoperability on the Pygeoapi side that you can call this and have pretty good support for this standard, and on the back end you can have a really scalable way to run whatever workloads you want to make available to your customers. So this has materialized by means of the Pygeoapi project. It is a Pygeoapi plugin, and it's ongoing work. Okay, so some of the stuff that I'm speaking about is already working, other is still work in progress. It allows basically so basically it consists of a custom Pygeoapi process manager that we just take out the core one from Pygeoapi and say use this one instead, and it can be used to run both the normal Pygeoapi processes or some Prefect-enabled processes that we can create. The way these things map conceptually is that in Pygeoapi we speak of processes, we speak of jobs, we speak of inputs and outputs. In the Prefect lingo, if you read their documentation, they speak of flows, flow runs, parameters, results. And then there are some concepts here that don't exactly map out to Pygeoapi, simply because they are enhancements of the Prefect system, okay? But the two main things is that we transform a Pygeoapi job into a flow run whenever we get an execution request. Okay, so as I was saying, we can run this with standard Pygeoapi processes, and we can also define new ones which add a little bit of sugar on top, if you will, to become Prefect flows with some well-known inputs and outputs which are documented and allow us to take advantage of the full Prefect feature base, like I was saying, running it wherever we want, storing results where we want. Okay, I'm mostly done. I just want to tell you, okay, this is a work in project, that's cool. What is there left to do? For further work, there are some things that we want to get into Pygeoapi in terms of improving the compatibility with version 1.0.0 of the standard. These are mostly to dealing with getting the request and the response schemas in line with what is in the current version of the standard. So I put them here because I don't want to forget what we have to do. But importantly, for this work, we need to get Pygeoapi to be able to refer to process results also by reference. Currently, it works mostly with the raw results that were generated. And in order to support storing things on S3 or remotely, we need also to be able to have this capability. And this will mean also some additional enhancements to the process manager base class in Pygeoapi, just to make sure that these enhancements will be available for using by other plugins who may want to do this similar things. And in Pygeoapi Prefect, our custom plugin, what we need basically to do is put in a lot of examples of how you can use it in different scenarios in putting results in different places, and eventually publish it to PyPy when we feel like it's really rock solid and ready for everyone to use. Thank you very much, and this is it.